So this lesson, we are going to be graphing functions, okay, with our tables and intercepts. So our success criteria is that you're going to be graphing tables and intercepts so that you can analyze key features of a linear graph. So linear graph is going to be a line, okay? You'll know that you got this when you can graph with tables, graph with the x and y intercepts, and graph word problems. Okay, and we're going to be identifying some key features of graphs, like maybe vertical lines, horizontal lines, if a graph is continuous and discrete. Okay, so we're going to be working with two variable equations. These have an infinite number of solutions to a two variable equation. The solution can be written. The solutions can be written as x, y ordered pairs. Okay, remember the x always goes first. We can plot the solutions on a coordinate plane to create a straight line. So graphing with tables, we're going to rewrite the equation in linear form. So we got to get the y on a side by itself. So we're going to solve for y. Then we're going to choose at least 3 values for x. I like choosing -1, 0, and 1 to ensure that my graph is going to cross my y-axis in its center. Then I'm going to make a table with these values, plot the points from the table, draw a line connecting the points. So, this equation is already written in y form. So it's already solved for y. So I'm going to create an xy table. I get to pick the values for x because they are independent. So they never change. So I can choose, I like choosing -1, 0, and 1. We are going to substitute those values in for x and solve for y. So I'm going to have y equals -1 plus 2. So negative times -1 would be +1, plus 2 would be 3. So my y value would be 3 here. Now I'm going to substitute 0 in for x. So y equals -0 plus 2 equals, so -0, so that'd just be 0, plus 2, so 0 plus 2 is 2. So this ordered pair would be 0, 2. Now I'm going to substitute 1 in for x. So -1 plus 2 would be a +1. So this ordered pair would be 1, 1. Now I'm going to draw my graph. Plot my points. So my x value is -1. My y value is 3. My x value is 0. My y value is 2. My x value is 1. My y value is 1. Draw my line. And then we're done. Okay? So, is my next equation solved for y? No. So I need to solve for y first. So I have 3x plus 2y equals 1. So I'm going to subtract 3x from both sides. So I'm going to get 2y equals -3x plus 1. Then I'm going to divide by 2 to get y by itself. So I'm going to have y equals -3 over 2x plus 1/2, because I'm going to divide both terms by 2. So now let's solve for y. I can substitute values in for x and solve for y. Okay? So I'm going to make my ordered pair, or my chart, my table. And I'm going to select the same values, 0, or -1, 0, and 1. Okay? So I have y equals -3 over 2 times -1 plus 1/2. So a -3 over 2 times -1 is going to give me a positive 3 over 2 plus 1/2. 3 plus 1 is 4, and 4 divided by 2 is 2. So that's going to give me a 2 there. So now I'm going to substitute in 0. So y equals negative 3 over 2 times 0. Anything times 0 is 0, so this is going to just be 1/2. And I'm going to substitute in 1 for x. So I'm going to get negative 3 over 2 plus 1/2, which will be negative 2 over 2, which is negative 1. I'm going to draw my graph. Plot my points. So I'm at negative 1 is a positive 2 for my y. At 0 is 1/2, and at positive 1 is negative 1. Draw my line, or connect my points. Stop talking, please. And that is my graph. You should be copying this down. It may not fit inside that little box. You might have to use a separate sheet of paper. Okay? So that is graphing with the table. Now we're going to be learning about x and y intercepts. You got it? So x and y intercepts. An x-intercept is the point of the graph that crosses the x-axis. The y-intercept is the point on a line that crosses the y-axis. So this is my x-axis here. This point is my x-intercept. Okay, it's at 2. What is my y value anywhere on my x-axis? 0. What if this is my point here for my y-intercept, which is at 3? What is my x value anywhere on my y-intercept? 0, right? So if that's the case, when we are solving for our x-intercepts, we're going to plug in 0 for y, because it's always going to be 0 for my x-intercept. We're going to solve for x, and we're going to write our solution as a ordered pair, x, comma, 0. When we're finding our y-intercept, we're going to plug in 0 for x and solve for y. And we're going to write our solution as a ordered pair, 0, comma, y. Okay, so it says find the x and y intercepts of the equation. So I'm going to find my x-intercept first. So anywhere that there's a y in my equation, I'm going to substitute 0 and then solve for x. So I'm going to have 2x plus 3 times 0 equals 6. So I'll have 2x equals 6. Divide by 2. X equals 3. So my x-intercept is going to be 3, comma, 0. My y-intercept, we're going to do the same thing, except for we're going to plug in 0 for x. So I'm going to have 2 times 0 plus 3y equals 6. So 3y will equal 6. Divide by 3. Y is going to equal 2. So this ordered pair would be 0, comma, 2. So my x-intercept is going to be 3, comma, 0. And my y-intercept is going to be 0, comma, 2. Alright, so let's solve for x here. My x-intercept. I'm going to have 3x minus, I'm going to put a 0 in for y, equals 4. So that's going to be 3x equals 4. I'm going to divide by 3, and x is going to equal 4 over 3. So this intercept is going to be 4 over 3, comma 0, my x-intercept. My y-intercept, I'm going to do the same thing, except for we're going to substitute in 0 for x. So 3 times 0 minus y equals 4. So negative y equals 4. Divide by negative 1. And y will equal negative 4. So this, my y-intercept would be 0, comma, negative 4. So my x-intercept is going to be 4/3, comma, 0. And my y-intercept is going to be 0, comma, negative 4. Okay. So graphing with intercepts, you find the x-intercept, you find the y-intercept, you plot the intercept points, you connect the points with a line. Okay? So, this one I'm going to be looking for my x-intercept first. So I'm going to substitute 0 in for y. So 4 times 0 is 0. So I have x minus 2 equals 0. I'm going to add 2 to both sides, so 0 plus 2 is 2. So x equals 2. So my ordered pair here is going to be 2, comma 0. Then I'm going to find my y-intercept. So I'm going to substitute 0 in for x. So 0 minus 2 equals 4y. Negative 2 equals 4y. Divide by 4. Negative 2 over 4 is the same as negative 1/2. So this ordered pair would be 0, negative 1/2. I'm going to draw my graph. At 2, 0, I'm going to plot my x-intercept. At 0, negative 1/2, I'm going to plot my y-intercept. And then I'm going to draw my line. Okay? Okay, let's do the same thing here. So x-intercept, I'm going to substitute in 0 for what? Y. So 4x is going to equal 40, divide by 4, and x is going to equal 10. So my ordered pair is going to be 10, comma 0. We're going to do the same thing for my y-intercept, except for I'm going to be substituting in 0 for what? X. So 4 times 0 minus y equals 40. So negative y equals 40. Divide by negative 1. So y will equal negative 40. So this ordered pair would be 0, comma negative 40. I'm going to draw my graph. I'm going to number by tens. going to plot my points. So I have 0, 10, and or 10, 0, I'm sorry, for my x-intercept, and then 0, negative 40 for my y-intercept. Connect my points with a line, and there you go. Okay, now we're going to be looking at our word problems. So, with a word problem, we have to still identify our variable. So, for this word problem, we have you charge $8 an hour to babysit and $10 an hour to clean. If you need to earn $200 in a week, how many hours of each activity would you have to do? Write and graph an equation to determine this. So, anytime that we're writing an equation, we have to identify our variables. So I'm going to have x and y, because I know that I'm having a graph. My x variable is going to be the first thing that's mentioned, babysitting. And my y is going to be my second, which is clean. Okay. Then I'm going to write my equation. I have $8 per hour for babysitting, so that's going to be 8x. Plus $10 an hour for cleaning, so that's going to be 10y. And we're going to have this equal $200. Okay? I'm going to solve for my x and y intercepts. So I'm going for my x-intercept, I'm going to substitute 0 in for what value? Y. So I'm going to get 8x equals 200. Divide by 8. X is going to equal 25. So this ordered pair is going to be 25, 0. Then I'm going to do the same thing. I'm going to find my y-intercept. What value is going in for x? 0. So I'm going to have 8 times 0 plus 10y equals 200. So 10y will equal 200. Divide by 10. Y is going to equal 20. So this ordered pair is going to be 0, 20. So now I'm going to graph my equation. So I'm going to go up by 5, I guess. So if I'm plotting 25 zeros, so 5, 10, 15, 20, 25, and 0, 0, 25, 10, 15, 20. Am I going to ever have a negative amount of hours? No. So this is only going to go into our positive quartile. So I could babysit for 25 hours and do 0 hours of cleaning and still get $200. Or I could clean for 20 hours and do 0 hours of babysitting. Or any combination that's in between here and here and get that $200 or $200. Alright, there's going to be some special case graphs. So vertical lines are in the form of x equals a number. You go to the x value on the coordinate plane and draw a vertical line. So anytime that you have x equals and it's just a number, it's going to be a vertical line. If you have y equals a number, you go to the y value on the coordinate plane and draw a horizontal line. So for vertical lines, we're going to have no y in the problem. And for horizontal lines, we'll have no x in the problem. So, what type of graph is y equals -2? Horizontal or vertical? Horizontal. So I'm going to go to -2 on my y-axis and draw a horizontal line. What type of graph is x equals 1? Vertical. So I'm going to go to 1 on my x-axis and draw a vertical line. Alright. So, the last type of graphs that we're going to be learning about are continuous and discrete graphs. So continuous graphs are unbroken. The x can be any amount. Discrete graphs are distinct, isolated points. The x has to be a specific number. So let's say that our graphs, this graph here represented the x values was number of people. I couldn't have a third of a person, okay? It's just not possible. So anytime that it's something that needs to be a specific number, then it's going to be discrete. You're not going to connect the dots, okay? Because you can't have the values that are in between. But let's say that my x values represented cups of sugar. I could have 1 1/3 of a cup of sugar. So all the values in between could be represented, so it would be a continuous line. Okay, so it would connect. So let's look at our examples. So the price of cheese, y, depends on how much milk, x, is used to make it. Graph the data and determine if the graph is continuous or discrete. So I'm going to draw my graph. These are all going to be positive numbers. I'm going to go up by 16s here. Plot my points 0, 1, 16, 2, 32, 3, 48, and 4, 64. Okay. Is this going to be continuous, where I can connect my points, or is it going to be discrete? So let's look at our x value, milk. Okay? Can I have 1.5 cups of milk? Yes. So I can have any value that's in between 1 and 2, or 3, 2 and 3. So this is going to connect, because any value can be represented for my x's. And so that means that this is continuous. Okay, so let's look at our next one. So let's look at the amount of money made from selling tires Y depends on the number of tires sold X. Graph the data and determine if the graph is continuous or discrete. So I'm going to draw my graph. Again, I'm not going to have negative tires. I'm going to go up by 20. So 20, 40, 60, 80, 1, 2, 3, 4. Plotting my points. Okay. Can I sell a person half of a tire? No. You're not going to sell a person half a tire. It won't work. It won't go in their car. It's not going to work. So is this going to be continuous or discrete? Discrete. So I cannot connect these points because I can't have those values that are in between. So this is going to be